Good morning. This is the e-learning lesson video for Math 1 for April 15th. Today's notes and homework are going to come from Module 8, starting on page 15, Task 8.3. We're going to be using the notes from earlier in the week to help us get through today's notes and the assignment. So I want you to make sure that you have these notes that we did on Monday and Tuesday. We did this for part of homework. Again, having this next to you as you do today's notes and homework assignment is going to be very helpful, because I'm going to be looking for these items specifically based on which quadrilateral we're working with at the time. Okay, so have this to the side. Alright, so we are given these two graph quadrilaterals, and part A is asking us to look specifically at ABCD, which is this quadrilateral right here, and asking us, is that quadrilateral ABCD a parallelogram? Okay, so again, we're looking at it and sure looks like a parallelogram. However, right, for what we need to be able to do is we need to prove it algebraically. Okay, so again, this is where these notes are going to come in handy. Okay, so since we're asked the question about a parallelogram, and we need to know that we are looking at trying to prove if these two characteristics exist for that figure. Okay, so again, a parallelogram has opposite sides parallel, meaning the opposite sides have the same slope, and then the opposite sides are congruent, which means the opposite sides have the same length, aka distance. Okay, so those are the two things that we need to be able to show, right, for problem 1a. Is this a parallelogram? Okay. Alright, so first thing we need to prove is, are the opposite sides parallel? So we're looking at side AB and side DC. Those are sides that are opposite each other. Okay. So again, back to the notes, it says opposite sides parallel. If opposite sides are parallel, that means the opposite sides have the same slope. So we need to find the slope. So we're trying to prove the first characteristic is that the opposite sides are parallel. Alright, so to prove the opposite sides are parallel, it's about, again, the opposite sides have the same slope. So we need to find the slope of side AB. So the slope of AB. So we're going to use, again, our lesson from yesterday. If we do rise over run, we do rise 0, run 1, 2, 3, 4, 5, 6. Rise 0, run 6. So that has a slope of 0. Or if you recall, we said that, right, since this side AB is a horizontal line, horizontal lines have a slope of 0. Okay, so we're going to do rise over run, or recognize this is a horizontal line. This has to have a slope equal to 0. Alright, so now we got to find the slope of the side opposite AB, which is DC. Okay, so the slope of DC. And we look at it, we can do rise over run, rise 0, run 6. Or we can see, hey, it's a horizontal line, and the horizontal lines have slopes of 0. Okay, so is AB and DC parallel? Well, since both of them have the same slope, then they are parallel. Again, going back to the notes. Alright, we're going to keep going back and forth to these notes. If the opposite sides are parallel, that means the opposite sides have the same slope. Now we need to look at the other two opposite sides, side AD and side BC. So again, it's about, if they are parallel, then we need to know something about their slopes. So we need to find the slope of AD. AD. Now that's not a horizontal or vertical line, so we need to do rise over run. So I'm starting at D, going up 1, 2, 3, 4. So rise 4, run 1, 2. All right, so I did rise over run to find the slope of AD. So it's rise 4, run 2. So I have a slope of 2. The side opposite AD is side BC. So I want to find the slope of BC. So doing rise over run, rise 1, 2, 3, 4, run 1, 2, rise over run, gives me a slope of 2. Okay, so because both sets of opposite sides have the same slope, that's telling us the opposite sides are parallel. So I can check mark this characteristic, say, okay, we got the first characteristic of a parallelogram figured out. So now we need to figure out, does this figure have opposite sides congruent? Opposite sides have the same length, distance. Okay. So, do that. Number 2, opposite sides congruent. So again, it's about the length. So again, opposite sides. So we're looking at AB, finding the length of AB. Well, AB is a horizontal line. We can find the length of that by simply counting the boxes. 1, 2, 3, 4, 5, 6. So the length of AB is 6. DC is the side opposite AB. So again, since it's a horizontal line, I can find the length very easily by counting boxes. 1, 2, 3, 4, 5, 6. Okay. So we know that opposite sides AB and DC are congruent. Right? But we need to check the other set of opposite sides, side AD and side BC. Now because AD is a side on a slant, I cannot count boxes. Alright, but again, from the lesson from earlier in the week, because it's a graph line, we can find the length of that line by using Pythagorean theorem. Right? We're going to go ahead and draw our triangle. Here's our right triangle right here. Right? So we have one side that is 1, 2, 3, 4, a side of 4. This side is 2. We want to find the hypotenuse, so we're going to use Pythagorean theorem. So it's going to be side squared plus side squared, all underneath the square root. Again, we are using Pythagorean theorem to find the length of this side. Alright, so when we do that, we get 4 squared is 16. 2 squared is 4, so this one's going to be the square root of 20. Alright, find the length of BC. Again, because it's a line on a slant, I cannot count boxes. We need to use the Pythagorean theorem. So we are going to draw again our right triangle. Here's our right angle. And again, we're going to count boxes. So this side is 2. This side is 1, 2, 3, 4. This side is 4. Using the Pythagorean theorem, side squared plus side squared, all underneath the square root. Alright, so it's going to be 16 plus 4 is 20, so the square root of 20. So these pair of opposite sides are congruent. And because we have both sets of opposite sides congruent, we know we can check that check mark that characteristic off. Alright, so we know, so we can say, is ABCD a parallelogram? And then we're going to say yes, because we check mark both of these characteristics. Okay, so now we need to look at EFGH. So this other figure, we need to see, is it a parallelogram? Okay, so again, if we're going to prove this to be a parallelogram, we need to do the same thing that we did with the first part, is we need to see, are the opposite sides parallel and are the opposite sides congruent? Okay, so again, we should be looking for the slope of the opposite sides and the length of the opposite sides. Okay, so what I want you guys to do now is I want you to pause the video and I want you to again find the slopes of the opposite sides and the lengths of the opposite sides. Okay, so we're checking to see if are the opposite sides parallel. So we're going to find the slope of EF. So here's EF, so we're going to do rise over run. So we go down 2, and then over 10. So here's my slope, down 2, so it's -2 over 10. And reduce that down to -1/5. Then when we find the slope of HG, again, rise over run, so down 2. But when I go over, I'm going over 11. Okay, so here we're going to see that even before I reduce it, that the slopes are not the same. Remember, for opposite sides to be parallel, going back to these notes, for opposite sides to be parallel, that means the opposite sides have to have the same slope. Okay? Because these are not the same slope, these opposite sides, EF and HG, they're not the same slope, then they are not parallel. So I'm going to put a big old X here, and because we did not satisfy that first requirement of opposite sides being parallel, we can answer, is EFGH a parallelogram? And we're going to say it's a big old no, because the opposite sides are not parallel. Okay, so I'm going to stop this video here right now. I want you to move on to video number 2, where we do example number 2 from the task. Okay, so go to the second video, which covers the second example from the task.